Welcome back. So we are now going to work on problem 6. Let fx be this function. For each point of discontinuity of f, and for each give the value of the point of discontinuity and evaluate the indicated one-sided limits. Okay, so notice this is a rational function, that is polynomial over polynomial. From our theory we learned a rational function is continuous on its domain. So what is the domain of this function? Domain is all those numbers where the denominator is not 0. So let's figure out where the denominator is 0. So this is your rational function. Let's factor numerator and denominator. Well, primarily denominator. X squared is common. What's left is x squared minus 8x plus 16. This also factors. So my function fx is not defined for 0 because of that factor and 4 because of this factor. All right. Now you have learned in pre-calculus how to graph something like this. 0 and 4 will give you vertical asymptotes, and then you just have to figure out where it's above or below the x-axis. I have drawn the picture here using matcha. So 0 and 4 are places where the function is not defined. In fact, you have vertical asymptotes. To the left of 0, if you plug in values, say minus 2, you will find a negative value. So that's what tells me it's going to negative infinity. Between 0 and 4, you can plug in 2 and see. 2 is of course giving you 0, but say 1, you will see it's negative, so it's going below, and so on and so forth. So which brings us to our question. Okay, so far all I have done is used pre-calculus. So based on this picture, we have to say infinity or negative infinity or such things. So the first point coming from the left is 0. At 0, your function is not defined. What happens to limit as x approaches 0 from the left? As I approach 0 from the left, I'm going to negative infinity. What happens when x approaches 0 from the right? I go to negative infinity. So that was the first C, that is 0. Second C is 4. What happens when I approach 4 from the left? I'm going to positive infinity. What happens when I'm approaching 4 from the right? I'm going to positive infinity. There are no more points. It's actually continuous everywhere else. So if we have extra boxes to fill, we just fill it with x. Now submit. Okay, so we are all correct. Next problem. Use the given graph of the function to determine the type of discontinuity. All right. So here is negative 1, negative 2, negative 3, negative 4. That is one discontinuity. Negative 2 is another discontinuity. 2 is another discontinuity, and then 4 is another discontinuity. So start from negative 4. What kind of discontinuity it is? It is a jump discontinuity. What about negative 2? Negative 2 is a removable discontinuity. It's only one point that's a problem. If I moved the point there, it's cleaned up, right? So only one point discontinuity, that is called removable discontinuity. At 4, likewise, that's the only problem there. If we could just fill that point, it would work. So that's a removable discontinuity. And x equals 4, well, it's a very bad discontinuity. See, from here it's going to positive infinity, negative infinity. So this is an infinite discontinuity. All right, next problem. You have a piecewise defined function. You want to answer a few questions, right? They are saying a function f is said to have removable discontinuity if both the following hold true. It's either not defined or not continuous. fa could either be defined or redefined so that the new function is continuous. So you want to just fix one issue. So notice the rule changes at -8. So you want to find the limit from both these sides. First, let's figure out what happens to the limit to the left of -8 and then from the right of -8. When x approaches -8 from the left, x is less than -8, so that's the rule I apply. So plug in -8 in your expression, you get 64 plus 16 times -8 plus 72. 64 minus 128 plus 72, that's a positive 8. On the other hand, let's figure out limit x approaching -8 from the right. That is, x is to the right of -8. You are going to plug in there. You plug in there and you get 8 again. So the limits agree. Limits from the left and right agree. But the value at -8 is actually -5. So the only way to fix it is if the value were changed to the limit. Now, if you just fix this, it becomes continuous. All right. Now, let's draw a picture of this. Draw a graph of fx just to figure out what's going on. So, on the left is a parabola. Okay. You know how to graph parabolas. So, I'm not going to go over that. I hope you will know. That's your parabola. First parabola. Okay, with a vertex for -8 for x value. The second one is a parabola going down, opening down, again vertex at -8. So what would be the graph of my function? Okay, so here we have drawn just two parabolas, but what precisely is the graph of this function, right? Well, you need the axis, right? So these are our axes, but more importantly, -8 is a important point. So somewhere here is -8. Okay. To the left of -8, that's your graph. So the first one, to the left of -8, that's our graph. Okay. So the limit being 8, to the left of 8, that's your graph. Okay. To the right of -8, that's my graph. There was a hole there which was actually filled at -5 somewhere here, right? But you fix it here and that makes it continuous. All right. Next problem. A function fx is said to have jump discontinuity. Okay. You know the meaning of jump discontinuity. The left and right limits exist, but they are not equal. Okay, that's how you jump. So show that this piecewise defined function has a jump discontinuity. Well, 3 is where rule changes. So let's find the limit x approaching 3 from the left. Compare it with the limit x approaches 3 from the right. So from the left, if you notice, just plug in 3, you get 34 in my case. Whereas when I come from the right, I have to use this last option. 3 gets me negative 17. So notice there is a jump. Alright. So from the left, I plug in 3, 9, 18, 7. That gets me 34. From the left is this piece, equal is this piece, so otherwise means greater than. So from the right, I have to use this. Negative 7 times 3, negative 21 plus 4, 17. Negative 17. All right. Submit. Next problem. Okay. That reminds me. So the graph of these two, this is the parabola part, the first part, until negative 3, rather at 3, 34. And then it goes down into a line. All right. Next question. Determine the point at which the function 1 over x minus 8 is discontinued. Well, you know the graph of this. You can use pre-calculus or use any gadget here. So this is the graph. 1 over x minus 8 is nothing but 1 over x shifted to the right. So somewhere here, what kind of a discontinuity is it? It is an infinite discontinuity. Okay, so I will stop this video now and I'll continue with the next video.